All right, this is electrical 2, module 4, conduit bending, module number 26204-20. A little bit of math in this chapter, but jumping right into it. NEC requirements for conduit bends. You're going to have trade terms. You're going to need to know all those types of conduit, or those trade terms for conduit bends, back-to-back bend. You should have had an electrical 1. You should know what conduit is. You know that an elbow is a 90-degree bend. It's important whenever they're going through their questions. An elbow is a 90-degree bend. A kick is a bend that's less than 90. You should have bent offset bends by now. You should know what a radius is. And then a sweep bend is a 90 bend with a larger radius than produced by a standard one-shot screw. So you might have a larger radius for larger wires or something to go in there more easily. My only highlight on page 1 is in 110, the minimum radius requirements. I've got the last 2 sentences on the page going into the next page highlighted. NEC, where it says to accomplish this, the NEC further specifies that the minimum radius to the center line of a conduit shall not be less than listed in table 1. There is a good reason for this rule. When bends are too tight, pulling becomes extremely difficult, and the insulation on the conductors may be damaged. So they're just saying, should have a, sorry, should have been on already. Here we go. So it's just saying that this is the radius right here. So you have a 4-inch radius right here. It can't be smaller than that because it would mean that this is tighter. So you would want a larger radius. That way it's easier to pull wires through that piece of conduit. 120, number of bends per run. Second sentence is highlighted in 120. The NEC specifically states that no more than 4 quarter bends, or a total of 360 degrees, may be made in any one conduit run between outlet boxes, cabinets, panels, junction boxes, or pull points. Cannot have more than 360 degrees of bends in any conduit run. We're going to go through the different types of bends. I've got offset highlighted over there, bullet point on the right-hand side of page 2. An offset consists of 2 equal bends. Offset consists of 2 equal bends, and is used when one conduit run must go over, under, or around an obstacle. An offset is also used at outlet boxes, cabinets, panel boards, and pull boxes, shown in figure 3. So this right here, this would be like a box offset. So these are 2 little 10-degree bends for this box offset. Up here at the top shows an air duct, so they're using 45-degree bends to get up and over that air duct. But it's 2 back-to-back equal bends. The saddle, first sentence of saddle is highlighted. The saddle is used to cross a small obstruction or other runs of conduit. So you can have a 3-bend saddle or a 3-bend saddle or a 4-bend saddle. So that's over in 1. So that's on the next page. You can see those jumping over those. On that picture on page 4. You've got this picture right here. I've got this saddle is highlighted. You would want to use a saddle bend in order to go over a square air duct. All right, so this would be a 4-bend saddle. Over here on the right, you have a 3-bend saddle to go over pipe. So if you're going over something square, you're going to use a 4-bend saddle. If you're going over something round, you can use a 3-bend saddle. You can see how to do those. We're going back to page 2. I've got the first sentence of kick highlighted. A kick is a single change in direction on a conduit run less than 90 degrees. You'll have several review questions come out of table 1. I've got some stuff highlighted, but you're going to have to refer back to table 1 for some of those review questions that are in the back of the book. but nothing else on pages 2 and 3. Page 4, still talking about number of bends per run. Page 4, the sentence right before the blue, right before the green note is a saddle, maybe as low as 60 degrees or as high as 180 degrees, depending on the types of bends used. So that just depends on how many bends you need and what size bends you're going to use. So if you used a 4-bend saddle and you use like they did back here, if this was a 4-bend saddle, you would have a 45, 45, 45, 45. So that would be 180 degrees of bends. So that's where it's saying you can have as high as 180 degrees of bend. You got section 1 review on page 5. I'm going to continue going. Section 2, bend distances. This is going to be the harder part of this chapter. They're going to get into a little bit of trig with this, so you're going to need to know a little bit of sine, cosine, and tangent. So you're also going to have to know the Pythagorean theorem to do these. So looking at page 6, I can see like whenever you're doing this math, this hypotenuse, you need to know that this hypotenuse, or on this picture with this right triangle and this, the distance between bends is always going to be your hypotenuse. So on this picture right on B that I've got up here on the board, I highlighted that hypotenuse of that triangle, and then I wrote in the side that's the distance between bends. It's the distance between the bends is the hypotenuse. For some of these right angle math, you're going to need to know, like I said, you're going to need to know the sine, cosine, and tangent. On page 7, they have all of what each of them mean. So this is SOHCAHTOA is kind of what I've gone with whenever teaching this in the past. There's some of this earlier math. SOHCAHTOA, so SOH, sine equals opposite over hypotenuse. Adjacent over hypotenuse. TOA, T-O-A, opposite over hypotenuse. So sine, cosine, tangent, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So if I have my triangle here, this is my right triangle. These are the two sides that you're using. So just depending on which ones you're going to use, you can have angle A or angle B. Then your sides are usually your hypotenuse, base. You need to know those. I have the cosine one highlighted, but you're going to need to know all of them. Down there below where you see the HOA defined, the sentence right below that is highlighted. Therefore, in figure 6b, the hypotenuse or distance between bends could be computed by using the following cosecant trigonometric function. Cosecant equals hypotenuse over opposite. So they're just saying that this angle, this right here, is going to be your distance between bends. Not going to go into this too much because I don't think actual electricians use this math too much. But right-hand side of page 7, that big paragraph right there, and the one after it are highlighted. Here's another example. In this case, a kick is to be made off the end of one piece of conduit. The angle of the kick is to be 30 degrees. The hypotenuse of the kick is 20 degrees. Determine how far off the surface the end of the kick needs to be when calculating the hypotenuse of a bend. The cosecant of the angle is multiplied by the side opposite if the angle and the hypotenuse are known. Then the inverse can be used to determine the side opposite. Therefore, divide 20 by the cosecant of 30 or 20 divided by 2 equals 10. The end of the conduit needs to be brought 10 inches off the surface to acquire a 30-degree bend. This process eliminates the need for a protractor level. Finding bend distances using the circumference. Flip it over to page 8 and 9. 221. You need to know how to find circumference. I have that equation highlighted. Circumference equals 2 pi r. You also can know that 2 times r is also equal to the diameter. So you can have circumference is also equal to pi times diameter. So depending on which one you have, you can use either. Down at the bottom left of page 9, the last couple of sentences down there are highlighted. With that in mind, you multiply 1.57 times the given radius. It will provide the linear distance from 0 to 90 degrees on the circle. The linear distance is known as the developed length in regard to the amount of conduit that's required to make a 90-degree sweep. So you need to know how to find your developed length or what your developed length is. Gain, 222. You've talked a lot about gain in electrical 1. My highlights for this are second paragraph, first sentence on the right-hand side of page 9. The gain for a bend is found by multiplying the radius of the bend times the gain factor listed in table 3, or on your bender, or by your known. So I have gain. The equation for gain is highlighted down below on page 9. So about the last thing on page 9, gain equals radius times the gain factor. So you can see your tables on page 10 and 11 for those gains. Gain factors are on 10. 223, applying math to a 90-degree bend. Last sentence in that first paragraph is highlighted along with the 2 bullet points. Before beginning to make the bend, you need to know 2 measurements: the desired rise or stub up, and then the take up or deduct distance of the bender. Those are 2 things you need to know when making a bend. On page 11, it's a fraction table. You have calculators. You're going to have a question come out of this fraction table and say what's one of these fractions equal to. You can use these fraction tables in places, but more often than not, calculators will be used. So that's all I've got for section 1 or section 2. Continuing straight on to section 3. Bending protractor, concentric bending. So this section is going to focus in on using a mechanical bender. Rather than your hand benders or hydraulic benders. Well, I have hydraulic benders in this section. So, general tips to keep in mind when using a portable mechanical bender. I've got the second bullet point on page 13 highlighted. When the minimum length stubs are being bent, the shoe tends to creep and deform at the end of the conduit and threads. Screwing a coupling onto the end of the pipe stops the shoe from creeping forward and protects the threads. Like I usually have, so that's just saying, like right here, if this piece of pipe gets too close to this little hook, you can put a union or something on there, or a connector, and it's going to catch that hook, and it's not going to pull those threads into that hook and mar them up. Page 14 and 15, charting a mechanical bender. So if you don't have the information on the side, you can go back and chart that. The highlight that I have in that is down the bottom left of page 14, second to last sentence down there. If different information is unavailable, the bender can be charted using a scrap piece of conduit. So it goes through and how to chart that. I'm not going to read through there. On page 16, last paragraph on page 16, I've got the second sentence in the last paragraph. The star mark seen on many benders is used for back-to-back bends. I don't think I have a picture of that, but you will see that star mark on most benders, and that star mark is only used for back-to-back bends. Section 320. Making mechanical bends, bending stub-ups. First sentence, you're going to have two separate questions come out of that 321 first sentence. Making a stub-up requires knowing the bender take-up or deduct for the conduit type and size. All right? So that's the end of section 3. Section 4. Electric and hydraulic benders. You're going to have a lot of different trade terms that deal with these specific benders, like ram travel and stuff like that. One-shot shoe, outside diameter. Well, I mean, you know what outside diameter is. But you're going to need to make sure you know those before going into this section. Nothing on page 19. Flipping over to page 20. 410, electric benders. Third to last paragraph on the right-hand side of the page. Skip the first sentence and the rest of the paragraph is highlighted. The switch is then pressed upward and held in this position to start the bend. As the pointer approaches the 90-degree mark, refer to the spring back chart for the size and type of conduit being bent. In this case, 1 1/4 inch rigid conduit, the chart indicates 95 degrees. Therefore, the pointer should pass the 90-degree mark and stop at 95 to allow for spring back when the conduit is removed from the bender. The stub up is ready for installation. So what I'll say about this is you need to try this stuff out. Sometimes whenever I ramp stuff and go on past it on the 95, it's a little bit too bent, and the spring back doesn't bring it back. So just test that out whenever you're doing big pipe and stuff like that. Eliminate dog legs, 411. First two sentences of 411 are highlighted. One of the problems that exists when bending an offset or a saddle is the creation of a dog leg. The dog leg occurs when the center line that runs through the length of the conduit is not maintained for both bends of an offset and for the 4 bends of a saddle. So you want to make sure you keep everything centered up, or you're going to have dog legs, stuff's not going to fit together. They'll do 412 using a table or plywood to find the added length. Speed benders, nothing's highlighted in those. Flipping over to page 22, hydraulic benders. Online test question 420, hydraulic benders. The hydraulic bender is indispensable for bending large conduit over 2-inch EMT. Out to the side, I wrote 4-inch RMC is bent with a hydraulic bender. There's no chance you're bending 4-inch rigid metal conduit with a hand bender. Down there, fourth paragraph, first 2 sentences are highlighted. The pump should have its fluid level checked periodically. Low fluid pressure will keep the pump from developing its rated hydraulic pressure. So if you're using one of these, the hydraulic pump is down here at the bottom. You want to make sure this little black tank is the hydraulic fluid. If it's leaking anywhere, you're going to lose pressure. So you want to make sure you got plenty of fluid and no leaks. 421, page 23, bending rigid aluminum, which is what we bend a lot in the shop here. Second sentence is highlighted. It is lightweight and corrosion resistant and has low ground impedance. That means that it transfers electric, like when you can use conduit for electrical bonding to ground. So piece of aluminum conduit is good for that because it has low resistance to ground, but it's also corrosion resistant. So if you have somewhere where stuff's getting corroded quite a bit, you can use aluminum conduit. Disadvantages, it's quite a bit more expensive. We've got one-shot bending, segment bending. I don't have highlights in those. So nothing on 24 and 25, 26 and 27. I don't have segment. 28, 29, no highlights. Moving on to page 30, concentric bends, 421. I'm at 424. Concentric bends, so you can see what those look like on page 31. That's where you're bending stuff the same. So it's not going to be the same exact bend every single time you do it. First sentence of 424 is highlighted. 2 or more parallel runs of conduit must be bent in the same direction. as shown in figure 42. The best results will be obtained by using concentric bends. Next paragraph, first sentence is highlighted. The second radius. So bend the first one, then you're finding the second radius. It's found by adding the outside diameter, or size of the first pipe, to the radius of the first pipe, and then the desired spacing between the pipes. In this example, the radius of the second bend would be equal to 24 3/8. So you take the radius of the first pipe, which is 20, the outside diameter of the pipe, which is 2 3/8, spacing between the pipes, which is 2. So radius of the second pipe is going to be 20 inches plus 2 3/8 plus 2, which means its radius will be 20 3/8 of an inch. Offset bends. 425, page 30, second paragraph, first sentence is highlighted. First, determine the offset needed, then find the degree of bend. Next, multiply the offset measurements by the figure directly under the degree of bend. So we've done offset bends. So you're going to need to know on page 33, it talks about if you need to find which letters, so they have them all marked out, A, L, S, S, R, V, like all those are different letters. So you just have to, if you want to find this one and you know this one, then you're going to use this. So you're going to have a question come back, and where you're going to have to use that for reviews in this section. It's going to be a module review question that's going to be used in that. Moving on to page 35, saddle bends, 426. Saddle bends, first paragraph and first sentence of the second paragraph are highlighted. You're going to have a couple of questions come out of that. As mentioned previously, saddle bends are used to cross small obstructions or other runs of conduit. Saddle bends in conduit made up of 4 inches inside diameter may be made in hydraulic benders. Always refer to the charts that accompany the bender. For example, to make a saddle bend on a length of 2-inch rigid pipe so that it can pass over 3 inches of pipe with a 1/4-inch clearance, 3 bending operations are required. So you can see down at the bottom or up here on the board, you're going to have 3 different bends. So you're going to have bend 1, bend 2, and bend 3. Just being honest, like I haven't done these a ton, but I use bend number 2 is usually my first bend, and then I bend the outsides after that. Right hand side of page 35, that I got that. What is it? The 4th paragraph on the page, first sentence is an online test question. For another example, suppose a 1-inch rigid conduit saddle is going to be built over an I-beam that is 10 inches in height. For that specific instance, you're going to use a 4-bend saddle. Going over pipe, something that's round, it's going to be a 3-bend saddle. Something that's square is going to be a 4-bend saddle. They go through the math on page 36 and 37 on how to do those. And then you got section review on page 38. Section 5, PVC conduit. First paragraph in PVC conduit is highlighted. Rigid non-metallic conduit and fittings, PVC electric conduit, may be used in direct earth burial in walls, floors, ceilings of buildings, in cinder fill and damp and dry locations. Its use is prohibited by the NEC in certain hazardous locations for support or fixtures and or other equipment where subject to physical damage and under certain other conditions. Refer to Article 352. So look at Article 352 if you want to find out where PVC conduit can be used. 510, joining PVC. Step 1 is highlighted. Conduit should be wiped, clean, and dry. Step 2, first sentence is highlighted. Apply a full even coat of PVC cement to the end of one conduit in the fitting. The warning on page 39 is highlighted. The cement used with PVC can be hazardous. Provide adequate ventilation, avoid skin contact, and always refer to the SES and follow the manufacturer's usage for safety instructions. Very potent. Catch a high or something using PVC glue inside a certain, like if you're under a house or something like that, make sure it's well ventilated. 520, bending PVC. Second paragraph, a little over halfway through, I got 2 sentences highlighted. Small sizes are ready to bend after a few seconds in the hot box. Larger diameters require 2 to 3 minutes depending on the conditions. So that's using one of these hot boxes like they have on the right here. They've got 1 or 2 of these in the electrical department. So this flips down. You can see the end of the electric heater in here. So you have these little wheels on the end. So you just continuously spin your piece of conduit so it heats up, and then you can mold it into whatever shape you want it to be. Moving on to page 40, last paragraph that's in the bottom left of page 40. Second sentence is highlighted. When bending PVC at 2 inches or larger in diameter, there is a risk of wrinkling or flattening the vent. To help eliminate this problem, a plug set is used. Plug sets are used with PVC that is 2 inches or larger. You can see a picture of a PVC plug set right there. So you have 2 plugs on either side. You fill it up with a very little amount of pressure, but it holds the outside walls from collapsing in when you're trying to bend it whenever it's heated up. Page 41, second to last paragraph, first sentence is highlighted. Expansion couplings are seldom required in underground or slab applications. That is my last highlight. That is all my highlights for the conduit bending section. Yeah, that's all I got.